Okay, so in this one, again, I do the same thing. I take x squared plus x minus 2 equal to 0. Now, to set this equal to 0, I actually factor, right? I am a big fan of kind of the trial and error method. I think it helps you see the problem best, but if you have another method, run with it, that's fine. I have an x here and an x here, a 2 and a 1. My 2 needs to be positive, my 1 needs to be negative. So according to our zero product property, this gives us x minus 1 is 0, or it gives us x plus 2 is 0. In math, that or means both are possibly true. So we get x is 1 or x is negative 2. We actually have two values that we are excluding from the set of all real numbers. So our domain is going to be negative infinity to negative 2, union negative 2 to 1, union 1 to infinity. And again, I do think that a number line is particularly helpful here because a lot of times that middle interval right here gets neglected. Okay, so you want to say from, we're at, say, negative 2 here and 1 there. So everything in between them is fair game for your domain. So this actually means, this may not be the most exciting information, but this actually means we're going to do our tables twice. Once for x is equal to, I'm going to do negative 2 first just because it's on the left most. It's further left, but it doesn't matter. I'm going to do this one first, and we're going to go once with the left here, and then we're going to go once with the right. And then we're going to come back and do the same thing with x is equal to 1. So we're going to have more work here, but that's okay. So let's set up our table. X, f of x. Okay, we're moving around x is negative 2. So as we approach that on the left, again, it may not hurt to just kind of draw it out. If this is negative 2, negative 3 would sit over here, and negative 1 would sit over here. So let's start at negative 3. Get my function again. Okay, just so I have it and I don't have to scroll back up for it. So that's negative 3 minus 3 divided by negative 3 squared plus negative 3 minus 2. So numerator is negative 6 divided by, that's 9 plus a negative 3, so that's 6, minus 2, and that's going to be 4. So this ultimately is negative 3/2. Okay, and let's try negative 2.5. So numerator, we have negative 5.5. Denominator, 2.5 squared, I have 6.25. And if we bring in that 4.5 with it, so we have 6.25 minus 2.5 minus 2. We're left with 1.75. If we divide, we end up with negative 3.1428. Okay, maybe negative, we're moving more in this direction, so maybe negative 2.1. Again, I'm okay with fewer over here, just, some of that's for the sake of time. Negative 2.1 minus 3, negative 2.1 squared minus 2.1 minus 2. Numerator, we get negative 5.1. Negative 2.1 squared is 4.41. and I get 0.31 in the denominator. So if we divide, I end up with 16.4516. Now, this is one of those cases where we had a pretty significant change. Negative 16.451. Now, this is one of those cases where if it's not clear, do another point. Negative 2.01, for example. If it is clear, if you do feel like you know what's happening, that's okay, right? If you feel like there's a clear pattern that's been established. And that's where some of that kind of intuition about this comes in, is just being clear on, am I able to justify what I'm writing down? I feel that in this case, that's fair, right? We can say as x goes to -2 from the left, f of x seems to be decreasing without bound. So we do the same thing over here. X, I guess these should be g of x's, shouldn't they? I did that on the last question too. G of x. I just assume everyone is f of x. So x goes to -2 from the right. What happens to g of x? So let's start again, very close. So how about -1.9, again, just to kind of mirror the last number that we did. So -1.9 minus 3, -1.9 squared minus 1.9 minus 2. Numerator gives us -4.9 divided by 1.9 squared is 3.61 minus 1.9 minus 2, we're left with -0.29. This gives us 16.8965. Okay, so then how about -1.5? So -1.5 minus 3, -1.5 squared minus 1.5 minus 2. So this is -4.5. Squared is 2.25 minus 1.5 minus 2, -1.25. Gives us 3.6, and that would be -1. So -1 minus 3, -1 squared minus 1 minus 2. So you've got -4. This would be a +1 and a -1. So those two cancel. Oh, that's crazy. Let's do it this way. Cancel like this. And we are left with -2, which is just a 2. So again, remembering that this one gets measured in this direction, I can highlight them, from 2 to 3.6 to 16.8965, it seems like this function is heading towards infinity for this group, right? And I did not highlight the last one. I should. Okay, so that's for this particular domain value we've taken out, right? And I'll come back and kind of summarize that in just a minute. But let's do the same thing when x was 1. Yeah, 1. So again, I'm just going to write the function so I can see it. Because it's g of x. That should be a G. I always default to F. X minus 3 plus X minus 2. Okay. So same exact story, but different number we're working around. So again, draw a number line, or it's good to just kind of have a reference point. If this is 1, that means 0 is over here, and that means 2 is over here. So we're looking at from the left, yeah. So we're looking from the left. Okay, so I would pick 0 to start, 0. So that's -3 and -2, or just 3/2. Okay, 0 is always a wonderful number to work with. Maybe let's try halfway. So that would be 0.5. So 0.5 minus 3 and 0.5 squared plus 0.5 minus 2. So this becomes -2.5 divided by, this would be 0.25 plus 0.5 minus 2, so -1.25. And if we divide, we end up with actually just a 2. Okay, and then maybe let's try 0.9. And again, if you don't see it, add more points. You have full control over that. Okay, so -3, that's not a 0.3, that's a regular 3, minus 3. So -3 and 0.9 is -2.1. 0.9 squared is 0.81. We have 0.81 plus 0.9 minus 2. So this becomes -0.29. And we end up with 7.2413. Again, I did just 3 on the last couple, mostly just because of the quantity that we're working with here. There's a lot more numbers in the last couple questions. But you can add another number if you feel like you don't see the pattern. So as x approaches 1 from the left, not f of x, g of x, seems to be approaching infinity. Same story, but from the right. X and g of x. So again, x is approaching 1 from the right side this time. So what happens to g of x? So to the right side of that, let's use 1.1. That would be comparable to this number up here, right, distance-wise. So 1.1 minus 3. 1.1 squared plus 1.1 minus 2, we get -1.9 over 0.31. And when we divide, we get -6 point, write that, -6.1290. Okay, let's try 1.5 minus 3, 1.5 squared plus 1.5 minus 2. So if we subtract, we get negative 1.5. My line is super not straight here. There we go. Divided by 1.5 squared is 2.25 plus 1.5 minus 2 gives us 1.75. And this gives us a negative 0.8574. And then let's finish this off with 2. Again, just kind of mimicking spacing and distance here. So that's 2 minus 3, and 2 squared plus 2 minus 2. That pair of 2's is just going to cancel on us. And we've got 2 minus 3, that's negative 1 over 4, or 0.25, negative 0.25, if we want to just match the formatting. Again, I forgot to highlight. I always forget to highlight the blue ones up here. So in our pink ones, in the second group on the right, again, remember we moved from here, so negative 0.25 to here, negative 0.85714, negative 6.1290. It seems as we move in this direction, we can draw that better, right? As we move in this direction, we'll call it better, it seems as if we are going more negative. Now, the other thing I want to point out is if you were to graph each of these, it should agree with what we're saying, right? So this is a perfect example of us kind of elevating something that's kind of familiar to us and putting it in more of a calculus or pre-calculus lens. So overall, how would we describe this function? Well, there were 2 of those values, so we have to be conscious of that, right? The first one was at negative 2. So as x approached negative 2 from the left, f of x, g of x, this is all g of x, isn't it? G of x approached negative infinity. As x approached negative 2 from the right, g of x approached infinity. And again, they don't always disagree. They do sometimes agree with each other. So don't assume one or the other. As x approached 1 from the left, g of x was approaching infinity. We saw that in that previous example up here, or the previous group. And as x approached 1 from the right, g of x is going to negative infinity. It's decreasing without bound. So this is kind of us describing behavior. It's a bit tedious. I can't promise everything we do is the most exciting thing of our lives. However, it's getting behind the concept. And the good news is we're not stuck with this forever. There are definitely more efficient ways ahead of us. We just haven't gotten there yet. And that's another huge theme of math, right? Mathematicians are always striving for efficiency. And when there's not efficiency, they look for some wherever they can, right? They develop new processes or methods or whatever it may be. So we just haven't gotten to that place in our class or in our math journey. We'll get there, okay? So bear with me. I know it takes a minute to get through.